On a clear, dark night in the northern hemisphere, you can sometimes see a faint oval hanging over the horizon, a ghostly smear of light. That smear is the Andromeda Galaxy, the nearest giant neighbor to the Milky Way. It looks peaceful, distant, eternal. It isn't. Andromeda is racing toward us at over 100 kilometers per second, roughly 250,000 miles per hour. Gravity has set the future on rails. The Milky Way and Andromeda are on a head-on path. One day the night sky will bloom with twisting streams of stars. Our galaxy will stretch, tear, and reform, and the map of the heavens will be redrawn. When galaxies collide, what happens to the stars, the planets, us? Tonight we fast-forward billions of years to witness the demise and rebirth of our home in the cosmos. This is the story of how galaxies die, how new ones are born, and where the sun might drift when the dance is over. The Milky Way is not alone. We live inside a small cosmic town called the Local Group. 3 big galaxies, the Milky Way, Andromeda, M31, and the Triangulum Galaxy, M33, surrounded by dozens of smaller dwarfs. Each galaxy is a vast island of stars adrift in a sea of dark matter. Invisible mass whose gravity sculpts their motions. The Milky Way, a barred spiral with perhaps 200–400 billion stars. Andromeda, larger still, maybe 1 trillion stars, sprawling, majestic. Between us, emptiness, thinly filled with plasma, dust, and dark matter halos that overlap like 2 soap bubbles drifting closer and closer. Astronomers once argued whether Andromeda approached or receded. In the early 1900s, spectroscopy showed its light was blue-shifted, a telltale sign of approach. A century later, the Hubble Space Telescope measured tiny sideways motions of Andromeda's stars and locked in the verdict: we're on a collision course. Here's the paradox. A galaxy collision looks violent, and it is. Yet stars almost never collide. Why? Because space is mostly empty. If the sun were a ping-pong ball in the center of a stadium, the next nearest star would be another ping-pong ball several thousand kilometers away. When 2 stadiums overlap, the balls rarely hit. So what does collide? Gravity wells, gas clouds, dark matter halos. As the dark matter halos interpenetrate, they tug on each other's stars. Orbits stretch into tidal tails that sweep tens of thousands of light-years long. Massive clouds of hydrogen slam together, compress, and ignite starbursts. Furious episodes of star formation. Central supermassive black holes gulp down in falling gas, lighting up as quasars that can outshine their entire host galaxies. From a distance it's a ballet, up close it's a storm. Long after our time, Andromeda will grow in the night, a bright spindle that crosses the sky. The Milky Way's spiral arms will begin to twist and warp as Andromeda's gravity pulls on them. The first close pass will drag out rivers of stars like glowing threads from both galaxies. Will Earth survive this first act? Almost certainly yes. The chance of a star physically hitting the sun is vanishingly small, but the gravitational tides can toss entire solar systems onto new orbits like corks being flung by colliding waves. From some vantage points, the sky will be breathtaking. 2 vast galaxies interlaced, with arcs of starlight bridging the gulf between them. Newborn star clusters will glitter like embers in the dark. If anyone is there to look up, they'll watch a slow-motion fireworks show that lasts millions of years. After the first pass, momentum carries the galaxies apart, but only for a while. Gravity reels them back. We'll see a second pass, perhaps a third, each reshaping their disks. With every encounter, gas clouds shock and compress, birthing brilliant blue star clusters. Meanwhile, older red stars drift outward, filling a stellar halo that expands like a glowing fog. The Triangulum Galaxy, M33, may crash the party. Some simulations suggest it could join the fray, either spiraling in to merge as well, or slingshotting around as a meddling third partner. Add a third dancer to any waltz and the steps become unpredictable. Orbits can get chaotic, and some stars are thrown far into intergalactic space. Through it all, the dark matter halos absorb energy like shock absorbers, gradually letting the system settle. At last, the cores of the Milky Way and Andromeda sink toward one another. At each center lurks a supermassive black hole, millions to billions of times the mass of the Sun. As the galaxies merge, those black holes spiral inward, orbiting one another like titans caught in a whirlpool. When they finally collide, they won't make a sound, but space-time itself will ring. A flood of gravitational waves will ripple outward, a last message to the universe that 2 great hearts have become one. In the aftermath, the spiral structure is shredded. The result is a new, larger galaxy, often called Milky Way, a smooth elliptical with a central, heavier black hole and a halo filled with the debris of two great disks. Here's the hard truth. The galaxy merger happens on about the same timescale as the Sun's aging. In approximately 5 billion years, the Sun will swell into a red giant, likely stripping Earth's atmosphere and baking its surface long before the galaxy fully settles. The collision isn't our downfall. The Sun's evolution is. Still, let's ask the fun question. Where might the solar system end up? Simulations give several fates. Still bound, the Sun could remain in the merged galaxy on a new elongated orbit, perhaps farther from the core than today. Kicked to the outskirts, gravitational tug-of-war could fling us into the extended halo, where the night is dark and thinly starred. Ejected, a small chance the Sun is tossed entirely out of the new galaxy, becoming a rogue system drifting between galaxies for eons. Whichever path unfolds, the most likely danger isn't impact, it's radiation. If our orbit takes us near an active feeding black hole, the galaxy's center could blaze with high-energy light. Most simulations, though, keep the Sun well away from that maelstrom. Imagine stepping outside at midnight during the first close pass. The Andromeda Galaxy would not be a faint smudge. It would be a luminous arc filling a huge swath of sky. Over thousands of human generations, a blink in cosmic time. Its shape would twist. You would see arched bridges of stars linking the two galaxies like luminous highways in the dark. New star clusters would spark in pink and blue along compressed gas lanes. Strip stars would form tidal streams, faint glowing ribbons curving from horizon to horizon. Constellations would slowly warp. The familiar patterns of Orion and the Big Dipper would be unrecognizable. The sky would be busier, brighter, stranger, less a map and more a living storm. Collisions are not cosmic accidents. They are how the universe grows. Early on, small clumps of matter merged into larger ones in a process called hierarchical assembly. Without mergers, you don't get galaxies like the Milky Way. Without mergers, you don't get ellipticals with their vast, ancient stellar populations. Even the Milky Way's own halo bears streams, ghostly traces of dwarfs we've already devoured. And collisions don't just destroy, they create. When gas clouds collide, they compress and trigger starbursts, flooding galaxies with new suns and new planetary systems. Somewhere in those future star nurseries, there could be worlds yet to form, and perhaps lives yet to wonder at the sky. Dark matter is the invisible stage on which galaxies dance. Each galaxy sits inside a massive dark halo, a roughly spherical cloud of unseen mass that outweighs the visible stars and gas by a factor of about 5. When halos overlap, dynamical friction, a kind of gravitational drag, robs orbital energy from the galaxy's cores, letting them sink together. We can't see dark matter, but we can watch its fingerprints, the way rotation curves of galaxies refuse to drop off with radius, the lensing of background light into arcs and rings, the distribution of satellite galaxies and tidal streams. In mergers, dark matter decides the tempo, how fast galaxies settle, how stars are flung, and how the final shape emerges. Today, the Milky Way's central black hole, Sagittarius A, naps. It occasionally burps out flares, but mostly it is quiet. A major merger is a wake-up call. Gas falling inward forms a hot accretion disk. Magnetic fields twist, jets launch at near-light speed. For a time, the merged galaxy could host a quasar, a lighthouse bright enough to be seen across the universe. This is not necessarily fatal to life far out in the disk. Distance is a good shield. But for the inner few thousand light-years, the sky would be harsh, bathed in high-energy light. If civilizations lived there, they'd have to look outward to gentler neighborhoods. Direct star-star collisions are rare, but not impossible, especially in dense clusters that form during mergers. When massive young clusters pack thousands of stars into tight volumes, close encounters can trigger stellar mergers, making blue stragglers, stars that look younger and brighter than their neighbors. Planets are more vulnerable, not to impact, but to gravitational disruption. A glancing flyby of another star at a few hundred astronomical units can jostle outer planets or Oort cloud comets, sending a rain of long-period comets inward. Over millions of years, these showers could spike impact rates. On a living world, that's a hazard, and perhaps also a catalyst stirring evolution's pot. If distant descendants, human or otherwise, exist when the first pass begins, the merger won't be a disaster movie. It will be a migration problem and an engineering challenge. Star-forming regions may provide raw materials, shifting orbits might force interstellar habitats to move, comet showers could necessitate planetary defenses, but most of all, it will be a spectacle. An entire civilization could grow up under a changing sky, its myths reshaped by visible rivers of stars. For beings who live on million-year timescales, long-lived AIs or uploaded minds, the collision would not be a moment, it would be an era. 3 quick myths to clear. We'll smash into Andromeda like cars on a highway. No, stars are too far apart. The wreckage is gravitational, not physical. The merger will kill all life. Unlikely. Risks rise near the center, far out in the disk or halo. It's mostly a sky show. This is happening soon, not in any human timeline. The first dramatic pass is about 4 billion years away. Long after the sun has already begun to brighten enough to sterilize Earth's surface. So why tell a story that won't unfold for billions of years? Because collisions are the heartbeat of galaxies, and their echoes shape the sky we see today. Streams and shells in the Milky Way, dwarf galaxies in tatters, even the tilt of our disk. These are footprints of ancient mergers, and knowing our fate binds us to the cosmos. We are not exceptions to its laws, we are examples of them. Even our galaxy is subject to change. Impermanence is not a flaw in the universe, it is its engine. One day, the Milky Way will meet Andromeda in a slow embrace. Tidal tails will arch across the heavens. Black holes will whirl and merge. New stars will flare into life from clouds compressed by the dance. And when it's over, a new galaxy will shine where 2 spiral giants once swirled. Will we be there to see it? Perhaps not. But that's not the point. The point is that we can know it. From a small world around an ordinary star, we have learned to read gravity's script written across billions of years. Look up at Andromeda, that faint smudge, and you're looking at our future. A reminder that even the grandest structures change, and that change creates beauty we can scarcely imagine. This is Skyward Space Quest. If this journey through the far future stirred your curiosity, like the video, subscribe, and join us next time as we continue exploring the stories written in the stars.